Welcome back, everybody. Ready for another deep dive?
Always.
Okay, awesome. Today, we're diving into the world of large language models, LLMs, for short.
Right.
You know, these things are everywhere these days.
Absolutely.
And you've sent us some seriously technical stuff about them.
Yeah.
Seems like you want to go beyond just what they can do, but really understand how these things are built.
Get under the hood.
Yeah, get under the hood. So, are we ready to unpack all this?
Let's do it.
Okay, let's dive in. You know, one of the things that surprised me when we were looking at all this material you sent us
Yeah.
was this idea that bigger isn't always better when it comes to these LLMs.
It's a common misconception.
Right. You would think just more parameters, more data, smarter model, right?
You think so?
But there's this thing called the chinchilla model that's really shaking things up.
It's a game changer.
Yeah, and we're going to get into that a bit later.
Yeah.
We'll also talk about why you might actually need to create your own WN LLM. Like, why would you do that?
Fascinating stuff.
So, I think a good place to start might be to kind of map out the life cycle of an LLM.
I think that's a great place to start when you're thinking about building a generative AI application with LLMs. You know, it's a journey. It's not just about the model itself. It's a whole process.
Yeah.
And the first big decision you face is, you know, are you going to go with a pre-trained LLM that's already out there, or are you going to take the plunge and train a brand new one yourself from scratch?
I bet there's a ton of pre-trained models out there, right?
Oh, yeah, tons. I mean, there are incredible resources like Hugging Face
Yeah, fucking fake.
and PyTorch, which are basically like vast libraries of pre-trained LLMs just waiting to be used.
Ready to go?
And the best part, each model comes with what's called a model card.
A mall card.
Yeah, it's kind of like a cheat sheet
Oh,
that
yeah.
tells you all about the model's, you know, strengths and weaknesses, what it's good at, and where it might fall short.
Super helpful.
It is. It's like having a personalized guide for choosing the right LLM for your specific needs.
So those model cards, I can see how those would be super helpful,
Totally.
especially when you're trying to navigate this whole world of LLMs.
Absolutely.
But whether you're using a pre-trained model or building your own,
Right.
it seems like understanding how they're trained is super important, right?
Oh, absolutely. I mean, that training process, especially what we call the pre-training phase,
Yeah.
that's really where the magic happens. That's where LLMs learn to understand language by, you know, basically devouring these massive amounts of text data.
It's a lot of reading for them.
A lot of reading. We're not talking about like a few textbooks here.
No.
We're talking, you know, imagine a library
Yeah.
the size of a small city, packed with books, articles, code, even social media posts, all of it.
Wow, I'm exhausted just thinking about that.
It's a lot. But the more an LLM sees, the better it gets at understanding all the nuances of human language.
Makes sense.
So during pre-training, the LLM is basically sifting through all this data, identifying patterns, you know, learning how words relate to each other, building this statistical map of language, figuring out the probability of, you know, certain words appearing together.
So all this data that goes in, I'm guessing they can use like pretty much all of it, right?
You'd think so, but actually,
Oh,
only a tiny fraction of all that data scraped from the internet is
But-
actually usable for training. We're talking like 1 to 3%.
wait, 1 to 3. What happens to the rest?
So the remaining 97 to 99% has to be cleaned up.
Okay.
It has to be processed to get rid of inconsistencies and errors.
Wow.
Imagine, going back to that library analogy, you have to go through all those books, make
Yeah.
sure all the information's accurate and relevant.
That's a lot of work.
It is.
So data quality is as important as quantity.
Totally. It's not just about feeding the model more data. It's about feeding it the right kind of data. That's a key takeaway, really, for anyone looking to, you know, get into LLM development.
Now, I've heard this, that not all LLMs are created equal.
No, absolutely not.
It's not just one size fits all.
No, not at all. There are actually different types of transformer architectures.
Transformer architecture.
Yeah, each one has its own strengths and weaknesses, kind of like specialized tools in a toolbox.
Okay, a toolbox. I like that.
So what kind of tools are we talking about? Well, there are 3 main types:
Okay.
encoder only, decoder only, and sequence to sequence.
Okay, let's start with encoder only. What are those all about?
So encoder-only models, also called auto-encoding models, they're like the master code breakers of the LLM world. They're trained using this technique called masked language modeling.
Masked language modeling. Okay.
Imagine you take a sentence
Yeah.
and you randomly hide some of the words.
Okay.
And the model's job is to predict those missing words based on the words that are still visible.
So it's like a fill in the blank.
Exactly. Like those exercises we all did in school,
Yeah.
but on a much, much more complex level,
Yeah.
obviously. And because these models look at the words, both before and after the masked word, they develop this, what we call bidirectional understanding
Directional.
of text, meaning they grasp the full context of the sentence.
So if I'm trying to figure out, let's say, the sentiment of a tweet,
Yeah.
like, is it positive, negative, neutral?
Yeah.
An encoder-only model would be a good choice.
Perfect choice. They're great for understanding, tone and the overall meaning of the text. Bert and Roberta are great examples of encoder-only models.
Okay, so we've got our encoder-only models for understanding context.
Mm-hmm.
What about decoder-only? What do those do?
Well, decoder-only models, sometimes called autoregressive models,
Okay.
they're like the storytellers of the LLM world. They're trained to predict the next word in a sequence.
Oh, like predictive text.
Yeah, exactly. Think about, when you're typing a text to a friend and your phone suggests the next word
Yeah.
based on what you've already typed. It's like that, but obviously on a much grander scale.
Uh-huh. So they're all about generating text that sounds natural.
Exactly, making it flow like human language. They're awesome at things like writing stories, composing emails, or even powering those chatbots that you talk to online.
Right, the chatbots.
And since they only look at the words that came before, they have a unidirectional understanding.
Unidirectional, okay.
So they're laser focused on what comes next. GPT and Bloom are two popular examples of decoder-only models.
Gotcha. So encoder only for understanding, decoder only for generating.
Right.
What about our third type, the sequence-to-sequence models?
The sequence-to-sequence models. Now, these are like the multi-talented performers.
Wow.
They combine elements of both encoders and decoders to tackle those more complex tasks. We're talking translation, summarization, even question answering.
Wow, so they can take a piece of text and, like, transform it.
Exactly. Imagine taking a long, complex article and having an LLM just condense it down into a short summary, hitting all of the key points, or translating a document from one language to another, capturing all the nuances of meaning.
So they're like the Swiss Army knives of the LLM world.
That's a great way to put it. T5 and BART are two great examples of sequence-to-sequence models. They're incredibly versatile and powerful.
Okay, this is all super fascinating, but I have to ask.
Yeah.
There's this common belief that when it comes to LLMs,
Right.
bigger is always better.
Yeah.
More parameters, smarter model, right?
It's a common thought, but it's actually a bit of a misconception.
Oh, really?
While larger models can do some pretty impressive things, it's not always as straightforward as just, bigger equals better.
So what are we missing here? What else matters besides the size of the model?
Two crucial factors often get overlooked: compute budget and the concept of compute optimal models. Understanding these is really key to building effective LLMs.
Okay, I'm all ears. Break those down for me. What are those?
So compute budget is essentially about the resources you have available for training. Think processing power, memory, the time you can dedicate to training your model. It's often measured in petaflop per second days.
Petaflop per second days.
Yeah, it might sound a bit intimidating,
It does.
but it's basically a way to quantify the amount of computation the model can perform in a day. To give you an idea, 1 petaflop per second day is roughly equivalent to running like 8 high-end GPUs
8 GPUs.
at full power for a full 24 hours straight.
Wow, so that's a serious amount of computational horsepower.
Oh yeah, serious horsepower. Now, how does this relate to compute optimal models? Well, researchers have found that there's this ideal ratio of data size to model size
Okay.
for a given compute budget. This means that just throwing more parameters at a model isn't always the best strategy.
So you can't just keep making it bigger and bigger and expect better results.
Exactly. You can actually get better performance by finding the sweet spot between model size, data size, and your available computing resources.
It's all about balance.
It is, finding that perfect balance. Now, this is where that chinchilla paper comes in.
The chinchilla paper.
This research paper made some groundbreaking discoveries about the efficiency of LLMs.
Everyone keeps mentioning that paper. What were some of the key takeaways?
Well, one of the most important findings was that a lot of large models are actually over-parameterized and undertrained,
Over-parameterized and undertrained.
meaning they have way more parameters than they actually need.
Okay.
And they haven't been exposed to enough data to reach their full potential.
It's like having a massive brain, but not enough experience to fill it up.
That's a perfect analogy. And what's even cooler is that they found this optimal ratio of data size to model size. 20.1.
20.1, okay.
For every parameter in the model, you ideally want 20 tokens of training data. This was a huge finding. It really prompted a reevaluation of how LLMs are designed and trained.
So before you just assume bigger is better, you need to consider the data you have available and aim for that optimal ratio.
Absolutely. The chinchilla paper really shook things up,
You did.
showing that these smaller, well-trained models can actually outperform the giants. It's a testament to the power of efficiency and targeted training.
That makes a lot of sense. But what about situations where even the most advanced, like general-purpose LLMs,
Yeah.
just don't cut it? What if you need a model that can understand, like, really specialized language, like legal jargon or medical terminology?
That's a great point, and it brings us to this fascinating area of domain adaptation. Sometimes you've got these super advanced LLMs, these general-purpose ones,
Right.
but they just hit a wall when they run into this, like, hyper-specialized
I
language.
can imagine.
Think about legal contracts.
Hell, legal contract.
All those crazy terms they use.
Yeah.
Or medical diagnoses.
Right, all that jargon.
It's like trying to decipher a secret code.
Coding.
You need a model that's fluent in that specific language.
Right, like it needs to be a specialist.
Exactly. And that's where domain adaptation comes in.
Domain adaptation.
It's this process where you basically fine-tune a pre-trained LLM on a data set of text that's specific to that domain.
You're tailoring it.
Yeah, you're tailoring it to excel in that one particular area.
Yeah. So like if you're building an AI assistant for lawyers,
Right.
you wouldn't want it getting tripped up by all those legal terms.
Exactly. I mean, those specialized terms are key to understanding those legal texts.
Yeah.
And without them, even the most advanced LLM is going to get lost.
It's like trying to read a medical diagnosis written in shorthand.
It is. It's practically a different language. So in those fields, you often need to create these custom LLMs,
Okay.
train on massive data sets of legal documents, medical journals, whatever that specialized field is.
So you're basically giving it a PhD in law or medicine.
Exactly. And a perfect example of this is Bloomberg GPT.
Bloomberg GPT.
This finance-focused LLM developed by, Bloomberg.
Right, Bloomberg. Makes sense.
They realized that the existing LLMs just weren't performing well enough on financial tasks.
Oh, really?
Yeah, they needed a model that could understand all the nuances of market data, financial news, and all that complex terminology.
So they decided to build their own.
They did. They created this massive data set of financial text, drawing on their, huge archives of financial data and news.
Wow.
And they actually used those chinchilla guidelines we talked about,
Oh, that's cool.
aiming for that optimal ratio of data to model size.
So what did they end up with?
A 50 billion parameter model.
50 billion. That's huge.
It's a beast, but remember, it's not just about size, it's about having the right data, the right architecture.
Right, right.
And the results were impressive.
I bet. Tell me more.
Bloomberg GPT achieved state-of-the-art results on a whole range of financial benchmarks.
Like what?
It could analyze market sentiment from news articles, extract key information from financial documents, even make predictions about stock prices with crazy accuracy.
Wow, that's really impressive.
It was like they created a financial whiz kid, but in LLM form.
That's a great way to put it.
It really shows the power of domain adaptation, to unlock the full potential of LLMs for these specialized fields.
It's like giving them a superpower.
It is. Bloomberg GPT is a testament to the power of focused training domain expertise. A great example of how LLMs can be tailored to revolutionize different industries.
So we've talked about the life cycle of an LLM, all the different transformer architectures,
Right.
compute budgets, the chinchilla findings, and now domain adaptation.
It's been quite a journey.
Has. But all this knowledge, it's only as good as what we do with it. Right?
Absolutely.
So I want to leave you with a thought.
Okay.
Now that you have a deeper understanding of how LLMs are trained, what they can do, what applications can you imagine? What problems could you solve with this tech? What amazing things could you create? The possibilities are, like, endless.
It's true. The more we learn about LLMs, the more we can use them to, make a real difference in the world.
It's not just about the technology itself.
Right.
It's how we use it to, really have a positive impact.
Absolutely. And that's what makes it so fascinating,
Yeah.
It's not just about pushing boundaries. It's also about making sure these tools are used responsibly.
That's super important.
It is.
Well, I think that brings us to the end of our deep dive on LLMs.
It does.
Hopefully you're walking away with, a better understanding of how they're built, how they're trained.
All their potential.
Yeah. And all the incredible things they can do.
It's been awesome exploring all this stuff with you.
Same here.
And remember, this is just the start. The world of LLMs is constantly changing, so stay curious, keep learning.
Keep learning.
Who knows what amazing discoveries are waiting out there?
Totally. Thanks for joining us on this deep dive.
Thanks, everyone.
We'll be back soon with another look at the, crazy world of cutting-edge tech.
See you then.
Until then, keep those brains buzzing.